Hello, I'm Petru and welcome to another lesson here on WellCode. This is a very important one and we'll talk about debugging, about how to debug your programs. You probably experienced the situation where you wrote a program and you thought that it's correct, but then when you ran it, you saw that it doesn't print the desired output for some examples, or you thought it's correct and even for your examples it printed the right answer, and then when you submitted it on the platform you didn't get the maximum score. Another situation is when you find a solution online, or when someone gives you a solution, a source code, and you're looking through it and you're not understanding it. You don't understand what's happening. And today I'm gonna present you a method which you can use whenever you want to find your mistakes in the code you've written, or you want to understand someone else's code. It's a very easy method and I hope you'll incorporate it and use it successfully whenever you're trying to solve problems. If you are watching this video on YouTube, don't forget to go on WellCode.com and start learning how to code with practical exercises and with lessons which have a lot of practical examples and which will develop your logical way of thinking. You'll start thinking as a programmer if you finish our course, so don't forget to go on WellCode.com. In order to illustrate how to apply this method, I took a problem from our problem archive. You find it on WellCode.com, and I'm going to show you how to debug the solution. I wrote a wrong solution and we will find the mistakes and hopefully fix them. The problem is the following. You're given a natural number n and you have to print yes if n is both prime and palindrome and no otherwise. A prime number is a number who has only two divisors, one and himself, and a palindrome is a number which is the same when you read it from left to right or from right to left. So for example, 131 and 747 are both palindromes, and 242 is a palindrome, but it's not a prime number. So the numbers here on the first row are palindromes and primes at the same time. So for each of those numbers we need to print yes, and for the numbers here in the second row we need to print no. And here's the program, and in order to debug it I created a table, and for each variable I created a new column. So we have n and copy, inverse, is prime and divisor. So we have a column for each variable, and we will do the same thing that the computer does whenever we click the run button, and we will write down in each row the values of the variables. I chose not to read data from standard input, even though you have to do that whenever you're solving problems on WellCode, but it's way faster just to initialize the variable with the value, and I don't need to switch between the program and the source code. I can just look at the source code. So this is the reason why I'm not reading data from standard input. And let's get going. Let's run the program for 7 and let's see if it prints the desired output. That's a yes. Okay, so I ran the program and I don't get any output here. It should output the number. So whenever you are running code, first of all you want to make sure that the reading of the input is correct, is done correctly, because you'll see as you progress through the course, some of the problems have much more complicated input, and you want to be sure that you're reading the input correctly. So in order to check this, I just need to print n and hope that the value printed out will be 7. So I'm running the code and I see here that indeed the program printed 7, so the reading is done correctly. And now let's write things in the table. Let's do the same thing that the computer does whenever we are clicking the run button. So here we are declaring, I'm gonna delete the print statement. Here I'm declaring n, I'm putting 7 inside the variable, and then I'm declaring two more variables, n copy, which will be 7 as well, and inverse, which will be 0 at first. So we have those three values. And then we go to the next line. While n is greater than 0, and we have to check this. Is n greater than 0? Well, n is 7, so is 7 greater than 0? Yes. That means we will go to the next line, and inverse will be equal to inverse times 10, which is 0 times 10, 0, plus n modulo 10. So this is the remainder of the division of n to 10. So here at this line, n will stay 7, and copy will stay 7, and inverse will be 7. So 0 plus 7, which is 7. And now we are going to the next line, which is n divided by 10, which is 0. But this value doesn't get stored anywhere, just n divided by 10, and the value is thrown away. Basically, we also have here a warning saying that the expression result is unused. Usually you won't have that in your IDE, but I'm lucky with this. So n stays the same. So basically we'll have the same values everywhere, and then the code which gets executed is line 13, which is while n is greater than 0, and n is 7, and 7 is greater than 0, so we will advance forward, and we have here inverse equals inverse times 10, so 7 times 10 is 70, plus n modulo 10, which will be 77, and then n divided by 10, which is 7 divided by 10 is 0, but we don't use the result, so the same thing will happen. And now this condition gets checked again. Is n greater than 0? And it will be, because n doesn't get changed. We can look here and see that over the last two execution of the instructions inside the while, n stayed the same. And we can see here the first mistake. This while loop will be executed infinitely. It won't stop. So this is the first mistake, and probably it has to do with a line which should modify the value of n, and this line is the reason why we have the infinite loop. And we look at this line, and probably if we want to process the digits of n, we want to divide n after we process each digit, and we want to divide it by 10, so we need to do this thing, like n is equal with n divided with 10. And this was the first mistake, and let's see if the program prints the desired output. So now we get the desired result for 7, which is yes. Let's try another number like 131, and we will get another yes. And now let's check a number which for which we should output no. Let's take 242 and see if the program is correct. And it's not correct. We get a yes, and we should have got no. So let's do the same thing again. We have 242, and let's see what happens. So at the first line, n is equal to 242, and copy is at line 12 242, and inverse will be 0. Then we have the while loop. Is 242 greater than 0? Yes, it is. It will advance to the next line, and here inverse will be inverse times 10, which is 0, 0 times 10, plus n modulo 10, which is 2. So inverse will be 2. And then at the next line, n will get divided by 10, so n will be 24. And then the condition of the while will be checked again. So is n greater than 0? Is 24 greater than 0? And it is. So the while loop gets executed again. And now inverse will be inverse times 10. So it's 2 times 10 will be 20 plus n modulo 10, which is, sorry, here is 24. So n modulo 10 is 4. So inverse will be 24. And now at the next line, n will get divided by 10. So 24 divided by 10 will be 2. So n will be 2 at the end. And now the while loop gets tested again. The condition of the while gets tested again, and is n greater than 0? Is 2 greater than 0? And it is. So we'll go to the next line where inverse equals inverse times 10. So it will be 240 plus n modulo 10, which is 2. So it will be 242. And at the next line, n gets divided again by 10. So 2 divided by 10 is 0, because in C++ the division is an approximation, is an integer division. So this will be a 0 here. And then the condition of the while won't be true anymore. So is n greater than 0? Is 0 greater than 0? No, 0 is not greater than 0. So we'll go to the next line where another variable is declared, is prime equals 1. And another variable is declared inside the for loop, and divisor is 2. And now let's see what the for loop does. So divisor equals 2, divisor times divisor, which is 2 times 2, 4, is smaller or equal than n. So n is 0, divisor is 2, so 2 times 2 is smaller or equal than 0, which is false. So that means that the for loop won't get executed. And we go to the next line after the for loop, which is line 21, and there's a condition which checks is prime is different than 0, and it is, it's 1, is prime is 1, or n copy 242 is equal to inverse, which is also true. So the printed result will be yes. But if I'm thinking about the role of the variable is prime, here it's obvious that the value is not right, because 242 is not a prime number. It should have been 0 here after the execution of the for loop. So there's probably something wrong with the for loop. And if we're looking at it, we see that n will be always 0, because here we have a while which won't stop until n is 0 or smaller than 0, but we're only doing division, so it can't get smaller than 0. So if we are at this line, n will be always 0. So probably here we don't want n. We want n copy, because we made a copy of n in order to keep the original value, because we want to check all the divisors of n. So here we need n copy. This is the first mistake, and let's see if the program is correct now. And now we run it and we get a yes. So the program is still not correct. I won't do the table again because we haven't changed anything at those lines. So we would have the same table until here. And now we want to check the for loop. So we have divisor equals 2. So divisor times divisor 4 is smaller or equal than n copy, which is 242. And this is correct. And here we got if n copy is divisible by divisor, so the remainder of the division of n copy by divisor is 0. So 242 divided by 2 is 0. Yes, it's 0. Then is prime will get 0. And then the for loop is executed again. Divisor increases, it will become 3, and 3 times 3 is smaller or equal than n copy, which is 242. And then the if will be executed again, and so on and so forth. I won't do all the steps because is prime has already become 0. If we look at those instructions, we see that the instructions inside the for loop don't do anything else. They just set is prime to 0. So I won't execute them until the condition gets false. And we arrive here at this line. So the condition is the following: if is prime different than 0, and it's not different than 0, so this will be a false, or n copy equals inverse. But n copy is 242, inverse is 242, so this condition will be true. So here we'll have a condition false or true, which is always true. False or true will be true. So the message printed will be a yes. And now we start to think. So in order to print a yes, we need that the number should be prime and palindrome at the same time. And here we're not checking those two at the same time. We check either one of those. So the or condition is not the right one. We need the and condition because we want them both to be true. And this is another mistake. And let's check now if the program runs correctly. And now I get a no. Let's check with other numbers. Let's take 747 and we get a no. Let's take 7 again because we changed the code and we may have changed other stuff and we may have introduced mistakes to some other part of code, but it's not the case right now. I get a yes. Let's also check 929 and we get a yes as well. So this method is very important. This is what a programmer does whenever he's writing code, because when you'll become a programmer, you will work in a team. Basically, you'll get some code and then you have to check the code for errors. Maybe there's an error and you get the task of fixing the error, or you just get some code and you need to build something on top of that. And in order to understand what the code does, you need to understand what the lines inside the code do. So this is a great method for finding that out. And also while you're training, this is a great method to figure out why your solution is not getting the maximum score, why your program is failing. You'll also see while you are training, as you practice this method, as you apply it, that you'll have variables popping up inside your head. You'll store all the values in your head just while writing code, and you'll see that you will find mistakes way quicker. And another great thing which the practice of this method does is that you will develop your logical way of thinking and your logical way of analyzing programs. And you'll see that as you are reading the code, you'll think about the logic behind every single line of code, because whenever you're completing the table, you're not just writing values inside it, you are also thinking at the same time what every line does, and you'll get that reflex, you'll get that habit of thinking what every line of the program does. And if you do that, you'll become a very, very good and very, very strong programmer, which avoids making mistakes. Every programmer makes mistakes every once in a while, but the difference between a good programmer and the bad one is the speed of which a good programmer can find a mistake. And there are also other differences, but this is a very big difference. Another trick which you can do in order to debug your program is to print the values of the variables. So instead of creating the table, I recommend creating the table while you're still a beginner. You can just print the value. So here I can print the value of inverse, I can print the value of n, and I can see for each execution of the instructions inside the while loop, I can see the value. So first, for the first pass, inverse will be 9, and then n will be 92, and then inverse will be 92, and then n will be 9. And this is another great way of checking your programs. And the last and maybe one of the most important thing is the testing of the program. As you may know, on WellCode you have only 1 or 2 examples in each program, and we do that on purpose. We want to force you to test your programs well on your own, on your machine. But if you see here, I took 8 examples, so 4 examples for yes, 4 examples for no, and I tested my program really well. And that's one thing that you also need to do whenever you're solving problems. You need to take more examples than the ones offered. You need to take additional ones and check that the printed result is correct. And you'll see this while doing interviews. If you apply for a company, you will get a problem, you have to solve it, and a lot of times you'll see that at the end they ask you, okay, you wrote this program, how do you test it? And they want to see that you know how to test your program really well, you know how to build test cases. If you look here, it wouldn't have made sense to add here another 3 or 5 because I already added a prime number composed of 1 digit. So you don't need to write lots and lots of test cases which are equivalent logically, but you need to write all the different possible test cases. So I took 1 prime and palindrome number with 1 digit, 1 with 3 digits. I took a palindrome number which is not prime, and a non-prime number which is also not a palindrome. Another thing to do is to check if for 0 I get a no and I get a yes, which is a mistake. And we can assume for this problem that n is greater than 0. Another edge case will be 1. And as you can see, for 1 I still get a yes. So here I need to check if n copy is smaller than 2, then is prime has to be 0 because 1 is not a prime number. And now I'm getting the right output. So don't forget to test your programs well. I hope this tutorial was very useful. I can't wait for you to finish the module. I hope you'll write a comment when you finish it and tell us what you like about it and what you want improved inside our course. And also, if you have any other questions, don't forget to leave a comment. We'll answer all the comments and we'll help you. And also, don't forget to be very careful, to be hardworking. And if you follow these steps, you'll become a very good programmer, and I wish you all the best.